All right, so I'm Annie. I work on Core Web Vitals with Michael and Scott. And I'm here to talk about some work I actually did on something different, baseline, or using baseline data to dig into web feature adoption. I did it with Brendan Kenny, who is now working on baseline DevRel. So some background on the work on Core Web Vitals and what this has to do with anything is that Core Web Vitals is a developer program where, well, it's both, right? We have these metrics of web page quality, LCP for how fast the page loads, IMP for how fast it responds to user interaction, and CLS, which is how much shifting around it does unexpectedly. And we try to get both web developers and Chrome itself to improve on these metrics to make the web faster and more usable for everybody. And so for that, we've done a ton of data analysis, a lot of it using HTTP archive. And some examples of successes we've had with that, both these projects we worked on with Gilberto Cochi from our outreach team. When we first launched interaction in XPaint, which is our responsiveness to user input metric, we looked at technologies especially third parties that show up on pages that can maybe cause slowdowns. And one of the easiest ones to find was those little cookie dialogues. When you click accept, by default, a lot of those, you click accept and then the page can do stuff. It does all of it synchronously all at once. And so we did a ton of outreach. We got a case study done and ended up having about a dozen cookie providers change the way that they do this to not block the dialogue from closing and you from seeing the content. And that improved interaction in XPaint on hundreds of thousands of web pages. Similarly, HTTP Archive has a full Lighthouse run. So Jill was looking at Lighthouse to see what are kind of the main BF cache blockers that show up on lots of origins. And he found surprising things like sites using WebAuthn and Bluetooth. And when he looked into it, the sites weren't actually using this. They had libraries that were doing feature detection, and then they never used those. So he went and talked to the people that own those features, and they narrowed the use cases in which they disable BF cache, and that made BF cache unblocked on hundreds of thousands of sites. All right, and we're back. So every time I tell somebody that doesn't work on Core Web Vitals about this, a lot of the time they ask me this question: hey, we work on web platform, we make new features for the web. Ideally, people use the features, they get adopted by developers. Can you do this kind of analysis to understand that better? They have a lot of questions they usually ask. How much does availability drive adoption? Are there common paths to adoption? How long should it take? What level of adoption do we even want? We can't answer all the questions, but I've been taking a look. So actually, I first tried to take a look at this about a year and a half ago. And we thought we'd use Blink use counters and then try and correlate them with, I don't know, stuff and see what we could learn. But it was really hard. There's 7,000 different use counters and there's no documentation. It's just whatever the engineer implemented. And when you try to figure out, this year, we were trying to figure out, what's the use counter for file system quota? And I mean, you can figure it out, but it takes time for each and every one of those 7,000 features. So now, fortunately, we have this WebDX community group, and they've been working on this same problem for totally different reasons. We would like to be able to present to developer a feature and kind of agree on what that is. Features have a definition, right? And so they've been working on this list. You can see it in Chrome status or on the new baseline dashboard of all these features. And they've got all this cool metadata for every feature. It's got a description that says exactly what it is. It's got categories and tags and groups, availability dates for every browser, and then baseline status. Real quick, since this is a big focus of what I was looking at, baseline availability is something we're trying to provide for every feature. Limited availability means it's not available in all major browsers. Newly available means it's been available in all major browsers, but less than 2 years. And then widely available means for more than 2 years. So as part of this, the Chromium side of this initiative, we asked everybody to implement this special WebDX use counter for WebDX features, which have been in Chrome since 2020. And everybody's been doing an amazing job. We've got 271 use counters, and they actually have a pretty good distribution of baseline availability. 115 limited, 103 newly, and 53 widely. And now we can really measure accurately the % of navigations in Chrome that each of these features is seen on, and the % of origins. I have a link in the slides for the spreadsheet to go after the rest. I'd love people's help with that. Okay, so what can we learn? The very first thing I did was try to make like some sort of chart that shows me like how does baseline availability correlate with usage. So basically, I took each feature and put the percent of navigations on the y-axis here that the feature is seen on. And then I grouped the features by baseline status, limited, newly, and widely, and put those 3 boxes on a box plot. So the top of the box plot is like the 75th percentile for the percent of navigations a feature is on. So you can see for limited availability features, like the 75th percentile is 0.4% of navigations. And then for newly, it's a 3%. But then widely, the box goes like the 25th percentile to the 75th goes from like 3 to 30. So that's really, really like one of the clearest, like we have a hypothesis and the chart shows it that I've ever seen, where you just dump the data on a chart and it says widely available features are more adopted. Another question that people ask a lot, the web has this like power law distribution where like the top sites are really, really popular. And then there's lots and lots of sites that are less popular. So on Chrome status, as you may know, we have a chart for each feature that shows the percent of navigations that feature was seen on. And a lot of people say, but what if that's just one site? We don't know what the sites are. How do we know? And so now we have this per origin and per navigation information, and we don't see anything up in that top left corner that would be just one site. We actually see like a pretty cool diagonal line that shows that a site's used on the same-ish percent of navigations and origins, which I found kind of cool and surprising. So what if we like kind of take that widely available thing one step further and we look at a feature's newly available date, we plot it on the x-axis and we plot the percent of origins on the y-axis. What we see is kind of like a down into the left curve, which would be expected, right? Like the more popular it is, the longer it's been around. But there's a ton of outliers on this chart. And if we split by the feature type, isn't this so cool? You could just, let me split on this, right? Like that's never been possible before. This WebDX features is so cool. We can see like it's a lot crisper for HTML and JavaScript. And then CSS is a lot messier of a plot. So all of this kind of made me wonder if like you look back at these high level outliers, right? Especially on this box plot, like what's going on up there? What are these features that are adopted so quickly? There's tons and tons of questions, but I thought this would be an easy one to poke into to start. So I'm going to use the same tool that I use for Core Web Vitals, which is the HTTP archive. If you're not familiar with it, it's a public data set that's a crawl that runs monthly on about 15 million sites, which have been seen in Chrome. It collects all the use counters, both the WebDX ones and the old 7,000 other use counters. It crawls all of the resources. It actually opens the page, and it does a lot of things when it opens a page, but one of the important things it does is detect about 3,000 technologies that might be running on that site. So what do we mean by technologies? There's a lot that it could do, but I kind of focused on 2 different types that I saw come up a lot as I did analysis. The first is like site creation platforms, both like shopping ones like Squarespace and Shopify, but also like just general ones like Wix and WordPress. And then on the other hand, third-party embeds and tools are something that's really, really common that I think we don't really maybe talk enough about. So this is like one little script or something that you put on your page. And maybe it gives you a cookie prompt, maybe it embeds like a map or a video, or maybe it's just an analytics script. So those are some examples of third-party embeds. And before I get too deep, people have a question, right? Like, are we sure that like if we look at HTTP archive, that's like it's like a lab run. It does a crawl. It doesn't actually use the features. I mean, it doesn't interact with the page at all. Is it going to be similar? And so I made another scatter plot, right? If we take the percent of HTTP archive usage on the feature on the y-axis and the percent we saw actually in real Chrome usage on the x-axis, we do again see this cool diagonal line with like a bunch of clunks at the bottom. So the 2 big ones at the bottom, they were actually features that right now when I did my run in March, it was Chrome 133, and those features are seen in Chrome 134. But I did look at a couple ones that are like way at the bottom here. Scroll to text fragment is an example. There are features that you won't see in the crawl. Okay, so since this is an engineering conference, I thought people actually want to know like how I did this. So I'll talk a little bit about how to dig in HTTP archive, but I have links in the slides to Google Colabs, which you can use to do this yourself. So the first thing I do when I look at like a feature and like what's using it is I take that technology detection and I make a chart like this. So this was Intersection Observer V2. You can see YouTube, 78% of origins that have like YouTube embeds are using Intersection Observer V2, and that's like 10. If we look at all YouTube embeds, that's like 10% of the origins seen on HTTP archive. And then you can see some other technologies too. So I think when we look at this chart, we're like, yeah, there's a correlation, but are you sure about correlation and causation? These things are both used on the internet a lot. So then what's really cool about HTTP archive is you can actually do a regex on all of the script resources that were loaded when the page was loaded. This is slow, but you don't have to literally do a regex on all of them, right? There's a table sample in BigQuery, so you can just sample it and find like the most popular ones. And my regex, it turned out it wasn't perfect, right? Like these do have Intersection Observer v2. I looked at this, it was a false positive. I was looking for is visible, and it does something totally different with is visible on Shopify and Stripe and Squarespace. So this is looking like YouTube is a source, right? And then I can take, but we see that like the same file shows up a bunch of times with a hash. So then what I did was I kind of like run a regular expression to see like how common is that file. It's on 8% of origins, which is really similar to the Intersection Observer usage. It's not quite on all of the origins that were detected using YouTube. So that makes a lot of sense. And then we saw some smaller usages. And then we can use a similar approach for CSS. The parse CSS table actually has AST. It doesn't have any white space, so you can just kind of run a regular expression on it. It's pretty awesome. Okay, so what do we actually know about the features that are adopted quickly? Well, first, what did I do for analysis? I took everything that's in those two box plots of limited and newly available features that are shown, that's seen on more than 6% of origin navigations and origins, but only limited and newly available because they're less than 2 years old. And then those ones gain popularity really quickly, and I wanted to see like what can we learn about how that happened. Okay, so first I saw a lot that were kind of like site building technologies really played a huge role. So fetch priority is a great example. It's used on 30% of origins, and if it's used correctly, it can make largest contentful paint a lot faster. WordPress has started using it since 6.3. It's on 22% of origins. Shopify uses it in their reference theme on 3% of origins, and Wix also uses it. So that kind of shows you like where is all that usage coming from. ARIA attribute reflection. YouTube embeds, again, like anytime they create an element, they're using ARIA attribute reflection to set accessibility properties on it. Same with Google Maps, although it creates fewer elements. Same with Next.js app router when it creates things. So similar story for compression streams, except instead of site creation, reCAPTCHA uses it, and that causes a lot of the usage there. We also see it not always used, but on YouTube embeds. And then Microsoft Clarity is a tool that allows you to like record and replay web sessions, and it uses compression streams to upload them. But then sometimes we see like a single third party that's really driving. So in that Intersection Observer v2 analysis, we're really seeing a lot coming from YouTube embeds. And then when I did that same analysis on string well-formed, I saw a bunch of different Google embeds, but they all had the exact same line of code where there's one specific library. This is like literally one line of code that's included in a bunch of places that accounts for nearly all the usage. And similar story for CSS and image formats adoption. So force colors is a CSS feature that allows you to like set CSS themes either in like high contrast mode or dark theme. So reCAPTCHA, again, uses that, which makes a lot of sense. You want to make sure that everybody can see the CAPTCHA no matter what color format's being used. Shopify has it in their reference theme. and Squarespace as well. Like it uses to underline links in high contrast mode. But that's like, a huge amount of usage comes from, like, again, a bit of a I don't know. I didn't expect that reCAPTCHA would be the big use case there. AVIF, image format. Big drivers of that are, again, site creation tools that automatically set the image to the best possible format. And then we do have some really, really bigger stories, right? Like an API is really, really popular, but you have some big parts of that usage. So HAS is used on 44% of origins. It's just super popular. There's no one explanation for it, but you do see a lot of site creation tools and some YouTube embeds using that feature, mostly for like really clear progressive enhancements. So if it doesn't work, it's fine. Container queries I saw on a lot of much smaller platforms. They were really trying to make sure that for different screen sizes, content showed up well. And then analytics was like a really, really big factor here I saw that I hadn't expected. So sometimes we did expect it. I work on Core Web Vitals, and these are two of the APIs that my team has made: layout instability measures, cumulative layout shift. It's used on a ton of different real user monitoring analytics tools. We also see like the Google AdSense and Publisher tab. They're actually using that to make sure that they're not causing layout shifts on the page. So that's interesting. And then long animation frames used by a lot of site creation platforms. But sometimes the analytics use case can really like propel something up high without which is again like one really surprising case. So scroll end is used in the new Google Analytics, and that's a huge percentage of the usage of that API, which is really not really supposed to be. As far as I know, it's more for like carousels and vertical scrolling things. It's not really meant for that use case. Similar for constructed style sheets, Microsoft Clarity uses this. They have the source code is open, and basically they're trying to record and replay a session. And when they're recording, the source code says that some frameworks are using constructed style sheets to create the page. So they override constructed style sheets, and that's a bigger usage than the frameworks that actually use it. Another thing that was really, really clear is that a lot of these features that are on the CSS chart way high up on the outliers, those actually have had fallbacks for a really long time. And like I could read the whole chart to you, but fallbacks or like progressive enhancements are so I think all of these have had some sort of fallback, and then people start using them more either with the fallback or the progressive enhancement. But that drives usage up a lot. I also found some outlier dots that they're a little bit confusing, where like I kind of don't know what to do in these cases. So outline had a small change in its baseline status was bumped, but it's been available actually longer than Chrome has. So saying that it's a newly available feature that's on 82% of navigations is a little bit misleading. Same for display mode. Its baseline status was changed to limited when they added picture-in-picture support, but this is measuring, as the name says, all display mode usages. And then Canvas 2D Alpha is like an optional on by default feature, and so we log it when it's on, but developers haven't actually turned it on. So I had some takeaways that adoption isn't always widespread success. And I think everybody should kind of look at like when your API is successful, like how is it being used? I do feel like the site building platforms and the stores are really setting a standard, and they might be somebody to consider collaborating with. And then like progressive enhancement, polyfills and fallbacks, they seem to be working really well. A lot of the cases I found were like either like really clear progressive enhancement or fallbacks being used a lot. But the whole reason I'm presenting this is I think it's just a really interesting area for discussion and analysis, and I would love to see more people talking about it. So this feature adoption channel is for more than just this analysis. It's a general area that Penny started to discuss feature adoption. So if you're interested, please join. And I think that's it. Got time for questions? Yeah, questions?
So I'm Stephen Cheney from Agalia. So one question related to the slide you had just a few back where you had like scroll bar, color, and then WebKit. Is there any sense of when we can deprecate WebKit scroll bar because WebKit, like where they always appear together, so then you can deprecate the one that's out of date?
I have a query for that, and the query is linked in the slides. It's backwards. It says anytime WebKit, anytime scroll bar appears, how often does WebKit scroll bar appear? But you could do the opposite query and see like all the CSS usages for every origin on like the 15 million sites.
Yeah, that'd be super useful for deprecation. And then I had another one related to, you said the queries you run the queries in Colab against BigQuery. Is that the Google internal version or is that the Google Cloud?
No, it's all external. The Colabs I linked, anybody can run. But I think the only thing I really don't like about Colab is like you have to, I made it like a dry run version that'll tell you the query, and then you have to paste it into the BigQuery thing to get the billing info. So be careful on billing.
Yeah, I discovered that a couple of days ago. Yeah.
But as long as you got that, then anybody can run the queries. HTTP Archive is a totally open data set, and Colab, I really like it because it allows you to put a lot of documentation into like what is this query trying to do, like why? Because I don't know if you ever read like a bunch of SQL without. It's really hard to read.
Yeah, so one thing, if you haven't already added to it, would be some sense of how big the query is to have an expectation of when you run it. What it's going to do.
Yeah.
That would be helpful.
Hi, Steve Kobus from Google. Do you know why Google Analytics is using scroll end?
I have not dug into it yet.
Oh, thanks.
Awesome.
Hey, Sam Goto from Google too. I was wondering if I work in a feature that is distributed via JavaScript SDKs, as you suggested, and I was wondering if you have any thoughts onto, because when we talk about adoption, you would expect like some sort of developer mindshare in terms of knowing that they're adopting them. So like if a feature gets distributed to a website without the website knowing because it has been embedded by a third-party thing, does it count as adoption or does it count as distribution? And the other aspect that I was hoping to pick your brains on is whether you can measure how fragile features are in terms of like if they get adopted very quickly because of JavaScript SDKs, can they also be dropped very quickly too? So yeah, just wanted to get your thoughts on.
So pretty much every time we measured adoption, we've just been reporting usually in percentage of navigations or percentage of origins. But yeah, we're not really trying to understand like, did the site use that intentionally? And I think that's something that I really learned when I was working on Core Web Vitals. Like most sites aren't really like built by a person intentionally using APIs. And I think it's something that we should be thinking about a lot. And like, how do we figure that out? And then the second question, one more time, I'm sorry.
Whether you have detected fragility,
oh, yeah.
like as in is there any correlation about things get adopted very quickly with things that die very quickly too?
Yeah, so I haven't seen that yet, but I think, remember, I tried to do this analysis a year and a half ago. We didn't have any data. Now we have a ton of data. So this is a point in time analysis just specifically because we didn't get data yet. But now we have, if you do have like an older use counter, you could do that analysis. Or like now we have ongoing forward going data. So we can do a lot more now than we could.
So Michael from Google, I have a fun anecdote to follow up with that one and then a question. So when scheduler.yield API shipped, there was a slow and steady ramp and then a sudden explosion in popularity. And that was really exciting. And we suspected that it was adoption and we had some insights that there was a popular library that switched to usage. So it was nice to see the spike, but we kind of knew it was one deployment. That's a good word. But we noticed that there was an equal and opposite decrease in another scheduling API for prioritized task scheduling of post tasks. So they went from one to the other. And it was much more exciting to see the sudden rise than to see the corresponding drop of the other one. So at least one anecdote that does exist. Both are pretty new APIs and similar story. My question, Annie, you mentioned that there was an increased uptake, adoption was better for like vendor prefixed CSS features. And I wonder if that's just like a one-time historical context because these are very old features that are now being interoperable, or is there possibly a lesson there to like, is that a pattern that should be used, or is, because I don't think it's.
I think it's not my area of expertise. Yeah. I'd be curious if like somebody who works on CSS knows if like
we don't like vendor prefixes because they live forever. We've learned this from what we're doing now. We're having to standardize all these WebKit features and try to navigate a path of deprecation. Often not possible. They're often going to stick around forever, but hopefully just be mapped to the standardized feature. We've not gotten into any serious thought about whether anything is good about them, because at the moment our ideology about it is just, let's just not do any of those anymore. If that is something you think we should think about, feel free to talk about it. But at the moment, we're just like, nah, bad. Don't do that anymore.
So one example that I did have though is container queries. Like for some use cases, you can run a media query instead. And my guess is that about like 30 to 40% of sites were doing that media query, but it's really hard to be very confident in your regular expression.
Hey, Kurt from Microsoft had one hypothesis for the media or the vendor prefixes going up is I know there's some frameworks that'll say, hey, you used a property, I'll automatically add all the vendor prefixes. Might be a hypothesis there. But I had a specific question, which is like, is there a way to normalize against hardware capabilities? Because if you saw like, you know, a pen API, it might not look as popular, but you know, relative to the percent of devices that have pens, maybe that is popular. Is there any thought about like normalizing against, you know, the broad universe of hardware, or is that just?
Yeah, so I actually want to address the first point in that, like, you can do regular expression queries and see like what's using this thing, and you'll see like all sorts of different systems that are you know, like all sorts of CSS, and it is kind of like, it feels like everybody copy and pasted the developer guidance individually. But then, yeah, what about APIs that that just we don't expect like every single device to adopt them? There's also like one of the, like I did look at not adopted APIs. I didn't have time to present on it, but like a bunch of new Canvas APIs are not well adopted, and I don't know how much API adoption we expect for those. A lot of like CJK specific APIs. There are a lot of things where, yeah, I wouldn't expect that to be adopted, but the longhand versions of font synthesis. And I think that's something that we should really think about more. And really one of the things that I'd love to be talking about in the feature adoption channel is like, when and why do we make it APIs that we wouldn't expect to ever go above 1%?
I just have another anecdote to follow up that question with. So there was one like problematic flow with forms on particular devices. And so we looked at the use counters for this particular feature firing. It luckily had a feature counter, and it was like a super low percentage of overall web traffic. But when you baselined it on the use case of like form submitting, like those are itself, like those are not that popular. But like when you are a user in the flow, which is a super important critical flow, that ended up being a significant fraction. And so it was important to baseline it to the use case.
Hi, Bramis from DevRel. Regarding the outliers that you mentioned for CSS, namely CSS has and container queries, the explanation for CSS has is it's awesome. It unlocks a lot of things that you can do in CSS, so developers are going all in on it. So it's an easy win. And then container queries specifically, there is a pretty solid polyfill out there that allowed authors to adopt the feature. So I think those two things might explain why those two are outliers in the whole thing.
Yeah. Yeah, with Has, I saw specifically a lot of progressive enhancement and then with container queries, is the polyfill use the media queries?
It's a JavaScript polyfill that can
okay.
polyfill actual container queries, and it sets up all the listeners for you. Yeah, it's pretty solid.
Nice. Yeah, it might be hard to detect, so I definitely didn't account for that.
Okay, I think we're out of time. So thank you very much, Annie.